This bit of Go code looks super simple, right? But the way it actually works trips up even seasoned developers. We're about to pull back the curtain on the hidden mechanic that causes this, and I'll give you a rock-solid mental model so you get it right every single time. All right, let's walk through this little puzzle. First, we create a slice called A with the numbers 10, 20, and 30. Then we create a second slice, B, which is just the first two elements of A. And finally, we change the very first element of B to 99. Seems pretty straightforward. So here's the million-dollar question. What do you think gets printed out when we look at the original slice A? I mean, common sense says it should be totally unchanged, right? We only touched B. But this is Go, and it's got a little surprise waiting for us. And there it is. The output is 99, 20, 30. Whoa. The change we made to slice B has somehow bled over and changed slice A. Now, this isn't a bug. It's actually a fundamental part of Go's design. So let's see what's really going on here. Okay, here it is, the absolute key to understanding everything. A slice doesn't actually store your data. Yeah, you heard me. Think of it more like a remote control for the data, which lives somewhere else. And that somewhere else is what we call a backing array. It's this hidden block of memory that holds the actual values. The slice variable that you use in your code is just a tiny, lightweight structure, a kind of window that gives you a view into that array. This window, sometimes called a slice header, is really just three pieces of information: a pointer to tell it where to start looking in the array, a length to say how many items it can see, and a capacity that tells it how much room there is to grow. And this is what solves our puzzle. When we created B from A, Go didn't copy the data. It just created a second window that pointed to the exact same backing array. So when we reached through B's window to change that value to 99, we were changing the data in the shared array. Of course, A saw the change. It was looking at the same thing. So we've